Extraneous solutions are found when you solve a radical equation and for some reason the answers don't work out. And it's usually because you can't take the square root of a negative, or the square root, uh, we're always considering it the positive square root, it gave you a negative number. So let's take a look here. You can see I've got an example equation written down. Root t plus 5 equals t plus 3. I squared both sides, and you can see I already just did the work here real quick. We'll do one of these in a second. I squared both sides. I looks like I got a quadratic. I factored the quadratic, and then I got two possible answers. I got t equals -1 and t equals -4. Well, I have to plug both of those in. -1 plus 5 equals -1 plus 3, and check to see if this works. -1 plus 5 is 4. -1 plus 3 is 2. Is the square root of 4 2? Yes, it is. Now let's try it on the other one. -4 plus 5, yeah. And -4 plus 3, okay. -4 plus 5 is 1, so I have the square root of 1 equals -4 plus 3 is -1. So this is where it gets kind of tricky. If the radicand itself had been -1, we would have just been done right there. And we could, oh no, that doesn't work. We're not allowed to right now. It can happen, but right now we're not allowed to take the square root of negative. We're also assuming that whenever we're dealing with one of these roots in these problems, we're dealing with the principal root, which means it should always be positive. And if you take a look here, the result is not positive, it's negative. So I would say t equals -1 is a solution, and the t equals -4 is extraneous. All right, let's go ahead and try that with example 3 here. So we've got our equation, and we're going to check our solution. Our equation is k plus 1 in a root equals k minus 1. I'm going to square both sides. I can do that because the root is all by itself. And I get k plus 1 equals k squared minus 2k plus 1. How did I do that so fast? Well, I noticed that was a perfect square, so I just used the perfect square pattern. That's going to be pretty handy for you. If not, just distribute it like normal. Let's go ahead and subtract 1 from both sides. So we get k equals k squared minus 2k. All right. And we'll subtract k from both sides because it's just a number and we can do that. We have 0 equals k squared minus 3k. And now I've got a quadratic, but I can do a greatest common factor here. I'm going to do the greatest common factor, and I end up with 0 equals k times k minus 3. Apply that zero product property, either k equals 0 or k equals, k minus 3 equals 0, which means k equals 3. So these are my two possible solutions, k equals 0 or k equals 3. Let's go ahead and give them a check. The square root of 0 plus 1 equals 0 minus 1. Well, 0 plus 1 is 1. The square root of 1 is not -1. So k cannot equal 0 because it has to be the principal root or positive. Let's try it with the positive 3. Square root of 3 plus 1 equals 3 minus 1. Well, 3 plus 1 is 4. 3 minus 1 is 2. And the square root of 4 is positive 2, so that one works. So k equals 3 is our only solution. K equals 0 is extraneous. And that's all it takes to do these. The big keys to all of these, let me see, did they give me one to break down? No. You have to isolate the radical, and that allows you to square both sides. solve like normal. So whatever method you need to use, whether it's just normal, multiple step equations, or you got to solve a quadratic, you have to solve it like you would normally would solve that equation when someone handed it to you. And the third step is check the solutions.